Hello everyone, and welcome to another lecture. And today we are going to discuss about groups. Mostly not go into details about group theory, but basically just try and understand the definition of a group and what do we mean when we say that G is a group. So we will basically be trying to understand that, and in some later upcoming lectures, we'll try and see how that is very important for us to know what is a group, because that will always help us in trying to understand some of the basic theorems of number theory and also proving them. So groups, so we'll try and understand what is a group. And the first question that is always up there is basically what we mean when we say that G is a group. So what we mean by this? So when we say that G is a group, we basically mean that G is a set along with a binary operation. So what we mean is G is a set along with a binary operation. Now, just for notation's sake, we can say that the binary operation is some kind of a dot, or some kind of this kind of symbol at this moment. It's kind of okay to say like this. So if G is a set, can be finite, can be infinite, along with the binary operation, and it follows certain rules, then we can say that G is a group. So it is important to understand that what are those rules in order to kind of define a group properly. So the first rule is of closure. So what do we mean by closure? It's pretty simple. If I take two elements A and B from the set G and apply the binary operator on A and B, then the new element that is formed should also be part of the set G. So that is basically what we mean by closure. Next comes associativity. Now I will use the black here. Oh, okay, sorry. So next is associativity. And what do we mean by this is we have, let's say, three elements A, B, C from the set G. Then if this thing holds true, then we say that the binary operator is associative. So the binary operator has to be associative, and the set elements will kind of will abide by the rules of associativity in terms of the binary operator. Okay, so now the third rule that needs to be followed by the elements of the set G as well as the binary operator in order for it to qualify to be called as a group is the set G should have an identity element. So what do we mean by an identity element? So by an identity element, we say that basically there is some element, or there exists some element I in the set, such that if I take any random element A from the set. Then if I apply the binary operator along with the identity element and the randomly selected element, then we will always get the randomly selected element. So that is what is meant by an identity element and existence of an identity element. And the last rule is also a very important rule, and it says that basically the set G, every element rather of the set G should have an inverse. So every element of the set G should have an inverse. So if I have an element A of the set G, then there should exist another element B in set G such that if I apply the binary operator on A and B, I should get the identity element. So, but usually, like in literature, often like it's used as or it is written as B is written as A inverse. So it's better if we kind of write it like that. Also, it's important to note that basically A along with the binary operator and B, whatever that is, should be equal to B, the binary operator A, and all of the times it should be equal to I. And so this is what is meant by the inverse of an element, and it says that basically if G has to be a group, then basically there should be like an inverse for every element A that is selected at random from the set G. So basically these are the primary rules that set G should follow along with the binary operator. The rules of like closure, associativity, existence of an identity, as well as like the existence of an inverse. If these are like followed, then basically you can say that okay, the set G along with the binary operator is a group. And the idea of a group is very important in order to understand certain theorems of like number theory, which we will discuss in the coming lectures, in order to later understand like the basics of cryptography. And I will be discussing more about like primitives of cryptography and modern cryptography, and hopefully you will be like enjoying the future lectures as well. So thank you for going through this lecture.